Okay, our today's topic is Bohr's atomic model. Very important topic in this chapter, the quantum numbers and Bohr atomic model. These are the very important topic because they are not only useful in this chapter, they are useful in entire chemistry. That's why it is important. I am not saying that directly questions will be there, but everywhere it is used. Because of that, these are very important topics. So let us start with one by one postulates. First postulate is an atom has a nucleus where all protons and neutrons are present, and size of nucleus is very small, very small as compared to size of atom. Okay, how much it is size of atom, you can imagine. See, radius of nucleus is 10 to the power of minus 15 meter, and radius of atom is 10 to the power of minus 10 meter, angstrom and Fermi. And we are going to make it cube because size is in terms of the volume. Okay, 4 by 3 pi r cube. Okay, so this will become, small will become more small, big will become more big. So this is going to be almost minus 45, it is going to be minus 30. So this is almost 10 to the power of 15 times bigger than this. Okay, so you have to be very careful. Size means don't think only radius, think in the terms of the volume, that is pi r cube. Okay, so first statement and this related question, is it understood? If the ratio of their size, they asked 10 to the power of 15, not 10 to the power of 5. Okay. Then coming to the second point. Next point is about the negatively charged electron. Negatively charged electron. Okay. Revolves around, revolves around, revolves around nucleus. Revolves around nucleus in circular, very important point, circular orbit. Okay, where where attraction force is equal to centrifugal force. What force? Centrifugal force. Okay, what is this centrifugal force, what is this attraction force, I will explain through the diagram. Okay, so Bohr atomic model we are studying. Right from the basic you should be able to understand. Let us take, this is a nucleus. This is the path followed by electron to revolve around the nucleus. This is nucleus contains nucleons. What are the nucleons? Proton and neutron are collectively called as nucleons. Okay. So while revolving this, there will be two forces. One internal force is attraction force. The force which is pulling it inside, it is the attraction force. Okay. The force which is pulling it outside force is centrifugal force. What force? Centrifugal force. Okay, so the place according to the velocity, centrifugal force will be there. According to the charge, attraction force will be there. Both should be matching. Then only this is going to stay. Then only it is going to stay in this orbit. Okay. Otherwise, it is not going to stay in this orbit. Is it understood? So if centrifugal force is more, then it will go outside. If attraction force is there, then it is going to come inside. If both are matching, then only it is going to continue to stay in this orbit. That's why orbit cannot be anywhere. If it goes that side, attraction force decreases, centrifugal force may dominate. If it comes inside, attraction force may dominate, it will come inside. So that's why only specified places are there. The orbit cannot be formed at every place. Okay, is it understood? Second point. So why orbit cannot be at every place, is it understood? If it is at this place only, both forces will be managed, both forces will be equalized. Okay, attraction force is controlled by potential energy, and that centrifugal force is controlled by velocity, that is kinetic energy. So both must be same, then only that electron is going to stay in certain orbit. Okay. Okay, we are into the next point. Out of the infinite number of possible circular orbits, just I told you, it can be below or above. So, but how to decide where it is possible? Out of the infinite number of possible circular orbits, just around the nucleus, the electron can revolve only in those orbit, only in that place. Okay, where where angular momentum, okay, where which momentum, angular momentum angular momentum of electron, okay, is integral multiple, which multiple, integral multiple of h upon 2 pi, that is n into h upon 2 pi. Okay, n is any integer, it should not be fraction. Okay, so that means here mvr, what is this mvr? Angular momentum is equal to nh upon 2 pi. This is very important formula, we are going to use it in further situation, so be ready for that. Okay, then this is about the which orbit it is able to revolve. Okay, next what is the next point? 3 points we have studied. Okay, now that orbits are called, fourth point is called as, orbits are called as stationary orbits. What they are called as? Stationary orbits. Okay, what is stationary orbit? That means till the time energy, stationary orbit. Okay, energy is constant till the time it revolves. It revolves in same orbit. It revolves in which orbit? Same orbit. Okay. So same orbit means, let us take, this is the nucleus. This is the first energy level, second energy level, third energy level, like that. Okay. So till the time electron revolves in this orbit, energy is fixed. That it is called as a stationary orbit. Okay. Suppose if it want to move from here to here, what it should do? It should gain energy. Okay. If it go back to the certain inner orbit, then it will revolve energy. So energy emitted and absorbed only possible. Emitted or absorbed only possible when it is moving from one orbit to another orbit. But till the time it moves in this orbit, it is called as a stationary orbit. Energy is conserved. Energy is neither required nor released till the time it is in the same orbit. Okay. Okay. Some more postulates are there. These are very important for the numerical side. Okay. E2 minus E1, that is energy gap between first and second is largest. The gap between the orbits are also not fixed. I have explained in the hydrogen spectrum also. The gap between the second and first is very large. This gap between third and second is small. Fourth and third is very small. Likewise, it keep on decreases. Okay. The gap between two consecutive orbital will keep on decreases. Okay. That gap between this is called as a delta E. What is the formula for delta E? Delta E is equal to, if wavelength is given, this is the delta Hc upon lambda. If frequency is given, h nu. Okay. So these are the some postulates. Now we are going to study some formulas related to the numericals. Okay. So formulas of Bohr theory. What is the next topic? Formulas of BOHR, Bohr's concept. Okay, Bohr concept formulas we are going to study. Are you ready? First one is energy of nth orbit. Okay, En. Is it understood? Main problem is that there are plenty of formulas. By changing in units, there will be change in value. Okay. So I will write all of them together so that you can compare and study. Okay. First formula we are going to study is about the energy. Energy of nth orbit is equal to minus 21.77 into 10 to the power of minus 12. Okay, this is the main value when it is in erg, and the people will get confused when there is a z and n, because further formula when you study there is something z in some formula z is in the numerator, in some formula z is not having square, somewhere it is square. So like that only confusion will be there. Okay, 10 to the power of minus 2 z square upon n square. Units will be ergs. And the minus 12 is replaced, multiplied with 10 to the power of minus 7. Then it will be converted into joules. So 2.21.77 into 10 to the power of minus 19 into z square upon n square joules. Okay. Now coming to the most useful formula in most of the numerical will be this one, 13.6 into 10 to the into z square upon n square electron volt. What is this? Electron volt. Okay. So these are the formulas which we have to utilize when question is regarding the energy. And all these formulas are per electron. If you are to find out per mole, then you have to multiply it with Avogadro number. Okay. Energy of electron in nth orbit. Is it understood? Okay, that is the total energy. Now we are going to study about the potential energy, kinetic energy, and total energy. Okay, so here this is the potential energy minus E square upon Rn, and with this is the kinetic energy plus 1 by 2 E square upon Rn. Okay, and total energy is minus 1 by 2 E square upon Rn. So there are many times questions are there. See, if you compare these two, kinetic energy is equal to half of minus half of potential energy. Is it understood? This is plus and this is minus. Here 1 by 2 is there. Okay. Second thing, total energy, if you and my uh, kinetic energy, total energy is equal to minus of kinetic energy. Kinetic energy will be plus minus if you're doing kinetic energy. Okay. And if you compare the total energy with the potential energy, total energy is equal to half of the potential energy. Okay. In the chemistry purpose, in the chemistry side, this is very important. Total energy and potential energy. Kinetic energy is half of the potential energy. Sign will be different. Total energy, kinetic energy, both are same, but sign will be opposite. Total energy and potential energy, sign is same, only thing is half is there. Okay. Instead of this formulas are very, very important. Okay. For the chemistry purpose. Okay. So in the physics, there are a lot of calculations about it, but we are not worried about it in the chemistry. Okay. Okay, coming to the next formula, it is the third formula, radius of nth orbit. Okay, the complete formula Rn is equal to h square into n square upon 4 pi square me square into z. But mainly these are all fixed values. Planck's constant, mass of electron, charge of electron, all can be substituted and simplified, and I have made it for you people, and I got it as 0.529. Okay, 0.529, and units are radius is will be in the angstrom. Actually, frankly speaking, this is the orbit, first orbit of the hydrogen. How you will come to know? For first orbit, n is equal to 1, z will be atomic number, so 1. So first orbit of hydrogen radius is 0.529, and you have to be take care here, n square upon z square, sorry, n square upon z, not square there. Okay, so in the previous formula, do you remember, main thing is z square are there, square is there or not, and it is in numerator or denominator. That is only the main problem. Okay, so that is the radius of nth orbit. Now we are going to study The fourth formula is about the velocity of electron which is revolving in the nth orbit. Okay, get ready. Okay, this is the velocity of electron revolving in nth orbit. 2 pi e square upon h. If you can remember this, it is better. Otherwise, you have to remember this. Okay, pi value, e value, h value, all substituted and done this. And the most important, again and again, I'm telling you, this you have to be, you should not confuse. Okay, in the energy, in the energy of electron, it is z square upon n square. In the radius, reciprocated and z square is not there. In velocity, see, it is just made ulta and square is not there. And this just a copy of it, but nowhere square in velocity. And 2.18 into 10 to the power of 8 units are centimeter per second. All the four formulas. What are the four formulas? Energy of electron in nth orbit, relation between potential energy, kinetic energy, and total energy. Third one is radius of orbit, nth orbit. Next, fourth one is velocity of electron in nth orbit. By using them, some more formulas are also derivated. What are those formulas? Number of revolution made per second or time taken per revolution. Okay. Fifth formula we are going to study. Okay, without using any new formulas, by using the old formulas only, new formulas are made. Okay, so time required per revolution. That means answer should be in seconds. Okay, for that, what we will do, we will total distance traveled upon velocity. Okay, distance upon velocity. So distance get cancelled, you will get time. So distance traveled, let us, this is the distance traveled. So if this is the radius, this distance will be 2 pi r, and the electron in which it is moving is velocity Vn. Okay. So this Rn formula already I think you remembered, but that is in angstroms. 0.0529, okay, into n square upon z, and units are angstrom. Here we have to convert them into centimeter because velocity we have studied in the centimeter. So velocity substitute to z upon n, okay, and here it is z square upon n square upon z. Okay, so everything will get cancelled. Answer will be, time will be in seconds. Make sure that this radius should be in centimeter. This is already in centimeter. Okay, this is the time when the question is how much time it will take to reach from here to back to the same. Now sometimes what they will give, number of revolution they will ask. What they will ask? Number of revolutions per second. Okay, number of revolution made by an electron in 1 second. So second should be not be there. Okay, just for that it will be Vn by 2 pi Rn. Okay, so this much distance it is able to cover in 1 second, and total distance will be this one. Rn means here radius of nth orbit. If number of revolutions are there, velocity in the numerator, time is there, velocity in the denominator. Okay, do you remember this? So this is about the Bohr concept. Right from the theory to the numerical, everything is covered. Now it depends upon how you deal with these formulas. Okay, I think you are happy with the theory. All formulas are combined together. Okay, so if you understand this formula, if you memorize this formula, the numerical session is going to be very easy. Bye bye. See you, and don't forget to press bell icon and share it to your one of your friend. Okay, bye.